What up, everybody? This is Mr. Stan coming at you with another physics video. This time we're talking about how to interpret a velocity versus time graph, all right? Now, a velocity versus time graph tells us how the velocity changes over time, all right? And so from this graph, we can obviously find the velocity at any given time, but we can also find the displacement and distance if we have the proper skills. And that's what this video is about, giving you the proper skills. So let's talk about how to find the velocity first, right? For instance, if the velocity is at 2 seconds, you'll find 2 seconds on the graph by looking at the horizontal axis and finding 2, right? And then find out what point that is on the line, and then find out where that is on the vertical axis. So in this case, it's 3 because it's halfway in between 2 and 4, and halfway in between 2 and 4 is 3. All right, so the velocity is 3 at this point. All right, what about 4 seconds? 4 seconds is right on the 0 line, so the velocity, therefore, is 0. Right, and then at 8 seconds, the velocity is -5. All right, how do we know that? Because -5 is in between -4 and -6, right, which is where this line ends up being on the graph. All right, so to find the velocity, you just have to look at where that particular time is on the graph. Finding displacement and distance is going to take another step, so let's see how to do that. All right, so remember, displacement tells you how far you are from where you started, and if we can find how far this object has gone, then we've found its displacement. So here's how we do it. Okay, for instance, what's displacement? 2 seconds. Displacement is going to equal the area. What do I mean by area? I mean the area from the graph down to the 0 line. Okay, if you shade in all the area and find the area, then you found the displacement. So let's do an example. Okay, so at 2 seconds, if I take everything before 2 seconds and shade it in between the graph and 0, then I get a little rectangle. Okay, and what's the area of a rectangle? It's equal to the base times the height, right? And so what's then you just find the base and height. The height is 3 because it goes from, this triangle goes from 0 up to 3, and then the base is 2 because it goes from 0 to 2 horizontally. All right, so base times height in this case would be 2 times 3, which equals 6. Okay, moving on to 3 seconds, we're going to do the same thing. Fill in a little rectangle there, which shows the shape of the graph from 0 to 3 seconds. All right, and then we find the area of that rectangle, which is 3 times 3. Right, and then base times height would be 3 times 3, which means the area is 9, therefore the displacement would be 9. So that tells us that at 3 seconds, this object has moved 9 meters away from where it started. All right, let's do 8 seconds. Right, we shade in all the area, and notice we only shade in the area between the graph and the 0 line. So from 3 to 7 seconds, where the velocity is 0, we don't have any area to add to it, right? So to start with, we have to include all the area from 0 to 8 seconds. So that includes that first rectangle, and we already found that first rectangle had a area of 9. Okay, but we also have to include this rectangle right here. Right, so between 7 and 8 seconds, time went forward 1 second. So it has the base is 1, but the velocity dropped by 5 meters per second. And anytime the area is below the 0 line, we're going to call it negative, right? So the area of this rectangle is -5. Right, and then to find the total displacement in 8 seconds, we're just going to add the areas of these two rectangles together, and we're going to keep the -1 negative, right? So it would be 9 plus -5, or 9 minus 5 is equal to 4. So displacement is 4. Right, now to find the distance, we're going to do the same thing, except in distance, we're not going to have any negatives. So we're going to treat everything like it's positive. If you want to find the distance at 8 seconds, you shade in all the area of the graph that's between the graph and the 0 line. That gives us 2 rectangles. Find the area of each of those rectangles, And this time, because we're finding distance, we're keeping it positive. Because remember, when you're talking about distance, you want to know the total amount of space that something's traveled, regardless of whether it's going forward or backwards. So this is obviously something that has gone forward a while and then come back. So we need to add together both parts of that journey, which would be 9 plus 5, and 9 plus 5 equals 14. All right, so the distance of this object traveled would be 14. All right, so that's how to interpret a velocity graph. All right, I will see you again in a future video.